go over how to solve for a missing side in a trigonometric ratio. That would mean that we have the degrees for one of the two missing angles. Let's say 33 degrees. Now keep in mind, if you have 33 degrees here, you can subtract from 180 to find the other missing one if you really wanted to. You could subtract the 90, you could subtract the 33. So that would give this angle as 57 degrees. So then if we had that, we could stand there and use that as a reference angle. But that's just extra and unnecessary, but a reminder that when you have one of the missing angles, you can find the other one. And of course the third one is always 90 if it's a right triangle. So trig ratios are with right triangles. You'll have a missing angle, so this will be our reference angle where we're sort of standing. Usually you're missing one side, so I will give this as a variable and make it an even 100 for the hypotenuse. So the first thing we want to do is label our hypotenuse. Stand at our reference angle and look across. That will be our opposite side. And our adjacent is next to the reference, but not the hypotenuse. It's the leftover one. So looking at this, we have a hypotenuse, and we're looking for the opposite. The adjacent is blank, so we're not going to be using it. We now look to our choices. We learn of SO, CA, and TOA to help us remember. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is the opposite side divided by the hypotenuse. So looking here, we have the opposite and the hypotenuse that we're going to be using. So that would mean we have to use sine, because those are the choice. That's the choice with opposite and hypotenuse. We then can begin solving. So we know we're going to use sine. We will say sine of the angle. The angle will always go there next to the word, because we're always getting the reference from that angle. We're standing there. Will equal the opposite side, which is x divided by 100. So the first thing we want to do is set it up. Using our ratio, we use the correct ratio depending on whether we have the opposite, adjacent, or hypotenuse, or if we have all three. Our second step is going to be to cross multiply. Cross multiplying is a shortcut to get rid of the denominator and get rid of a number on top. So what we're going to do is we're going to take sine of 33 equals x over 100. And what we want to do is put a 1 underneath sine. This gives us two fractions with an equal sign, which allows us to cross multiply. You cannot cross multiply without the equal sign there. So really it's doing two steps at once. It's the same as multiplying and dividing. So now that I crisscross, x times 1 is x, or 1x if you really prefer, equals sine of 33 times 100. So what we will do is we will go into our calculator and we will find sine of 33. So when we look at solving for an angle, we would have an x next to the sine or the cosine or the tangent. And to separate that, we would use the inverse button. When solving for a side, we don't need to separate x because it's already by itself. So we're going to take 33 and simply push the sine button just like it's written. We'll get 0.5446. Get the pen. Well, let's write it a little bit over here. I'm going to copy down the x and go back to our number. I think it was 5446. And you really want to leave all the first four numbers. That's typically what we used to do in the old days when we had a chart instead of a calculator. Because when you're multiplying by even bigger numbers than 100 especially, you're going to lose a bit if you just round to the nearest tenth. So we typically use the first four decimal places. You could round this one. I would if I were doing this just to be more accurate, but it's probably not too significant unless you're using really big numbers. So when we multiply, we get 54.46. Or a shortcut is when you multiply by 100, you're moving the decimal twice. So you can move the decimal over twice to get 54. So that's how we set up solving for a missing side. And it was pretty easy because the cross multiplying left x by itself. So let's do another one that isn't going to be as simple with respect to solving the algebra. And we have a video of how to solve using any algebra up through trigonometry. So that'll be another video to look out for. This time what we'll do is we'll give the hypotenuse as x. Just to change it up, we'll put the reference angle on top, 54 degrees, and we'll deal with the adjacent side instead of the opposite this time. So let's give, I don't know, let's give a big number, 1, 2, 3, 4. So we would imagine that you're standing here at the reference angle. You would always want to label your hypotenuse first because it never changes. It's across from the 90. So in reference to the little angle or the person, we would look across from it. That would be the opposite. And the adjacent side is the leftover one next to the reference angle. So in this particular case, we have hypotenuse again, and this time the adjacent side, the opposite, is blank. So we would go through our choices and see which trigonometric ratio has adjacent and hypotenuse. The trigonometric ratio that has adjacent and hypotenuse is cosine. So cosine of the degree 54 equals the adjacent 1, 2, 3, 4 divided by the hypotenuse. So I went A over H, adjacent over hypotenuse. Now I always prefer to get rid of the cosine or sine using a calculator at the beginning. I didn't really do that the first time. So I'll take 54 degrees, and again it's not being solved to get x away from the cosine. It's already by itself over here, connected to a number, but it's not connected to sine, cosine, or tangent. So I'm going to push the cosine button just like it's written, 5878 if I round it. 5878. And I'm just copying everything else down. So right here, I replace it with 0.5878. These two things are the same. So just like the last time, we set it up. And the next step is to put a 1 underneath and cross multiply. So this time you'll notice you have something next to the x. So I multiplied this way. 1 times 1, 2, 3, 4 is 1, 2, 3, 4. X times 0.5878 is 0.5878x. So we want to look at this as if it's a normal algebra problem without a decimal. If you said 2x equals 10, you would say 2 times x is 10, so we divide both sides. So we're going to do the same thing here. This means times, so we're going to divide both sides. And that's it. We'll just need to calculate it in the calculator. We got rid of the 5878, so x is by itself. So 1, 2, 3, 4 divided by 0.5878. Is 2099.35. So if we're rounding to the nearest tenth, it would be 2099.4. So when we are solving for sine, cosine, and tangent, we determine whether we are using SO, CA, or TOA, meaning we determine if we have an opposite, an adjacent, or a hypotenuse, which combination. If you have all three, you can choose either of them. I'll give you a quick example of that. If I had 3, 4, 5 here, and oh no, actually we're looking for a missing side, so one of them would have to be blank. And I had I don't know exactly. Let's make this accurate. So 4 over 3, I'm just going to cheat and get the answer of the angle. Second tangent, 53 degrees. So let's say that this is 53 degrees. We would begin to use our reference person, label your hypotenuse, label your opposite, and label your adjacent. So if we notice this time we have all three. So for sure we have to use the hypotenuse, because that's what we're looking for. But we also have a choice between using opposite or using the adjacent. So we really can use the hypotenuse, and that means adjacent we could use cosine, and for opposite we could use sine. I'll go ahead and use I'll use sine. So I'm going to use the opposite and the hypotenuse. So you want to make sure to mark that. I'm going to write sine of the reference angle is equal to the opposite divided by the hypotenuse. One of the first things I would recommend is to change from sine 53 to a decimal. So I'll take 53, click sine, and I'll get 7986. Now I'm going to cross multiply. So 7986 times x equals 4. I'm going to divide both sides to get x by itself. So our final answer, 4 divided by 7986, 5.008, over 5. Alright, I hope you got some use out of this. Take care.